Very good morning to all. This is Dr. Syed Nagina, Associate Professor in the Department of ECE, Electronics and Communication Engineering in SR University, Varangal. So this is my course, Digital Signal Processing Essentials from Signals to Filter. So here in this course, you will going to learn about what is a signal, that is basic definitions for the signals, how many signals, that is classification of the signal, then systems. So this is in this course you will going to learn about the basics of DSP systems and what are the applications of DSP in the real-time systems, and discrete signals, that is signal classification, how many types of signals are there, then how system, that is definition of the system and how system is classified, like different classifications we have for linear system, non-linear system, time invariant and variance, stable system, causal system and all. Then we have discrete time Fourier transform, and then you will going to learn about how to find out the frequency response using this discrete time Fourier transform. Then we have discrete Fourier transform. This is about the first unit 1, linear convolution and circular convolution. So first, as a basics of DSP system, so what is the role of DSP system in signal processing applications, and what are the practical examples of DSP system, what are the practical applications of DSP system you will learn. Now, introduction. So this session outcome is introduction to digital signal processing and understanding the role in terms of modern signal processing applications, and student able to understand what is a DSP systems. Coming to definition for signal, signal is nothing but it is a flow of information. It is a flow of information. So signal is nothing but it is a measured quantity either which varies with time or position or in terms of volume, anything. So anything that carries that is information is called the signal. In terms of electrical signal, so that is received from the transducer like microphone, thermometers, accelerometer and antenna, etc. So these are called a signal. So in terms of electrical signal that controls the process, right? Continuous. So there are two types of signals. One is continuous time signal and second one is a discrete time signal. So in terms of continuous in nature, if amplitude as well as the time is continuous in nature, like if you are considering this sinusoidal signal, right? So this is continuous in nature. So this type of signal we can call it as a continuous time signal. So amplitude is continuous as well as the time also continuous. Now in terms of discrete time signal, as an example, the minimum and maximum temperature lap intervals in risks. So sample continuous signals. In terms of discrete, so how we will get the discrete time signal? So we have continuous time signal. The signal applying a sampling and it converts continuous signal into discrete time signal. Continuous time signal into discrete time signal. So coming to this system, the first signal, flow of information, classification of the signal, that is continuous time signal and discrete time signal. Then we have system. System is nothing but it is a contains a set of elements together in order to perform certain operation, right? So system will have a definite input and it has a definite output. So it has input, that is system. So this system may perform processing, signal processing, it may perform amplification, it may perform filtering, it may perform synthesizing, it may perform the analyzing. So analysis, synthesis, so depending upon requirement or application, it may be used for signal processing from one point to another point, like audio processing, image processing and video processing, amplification or filtering process or synthesizer process or analysis process. So this is called it as a system. The system, nothing but it will perform a signal processing application. So it has input and it has a definite output. So this is the definition for the system. Now we have the same system. So system depending upon the which type of input. Depending upon type of input, system again classified as two types. One is continuous time system. Second one is discrete time system. If you are giving continuous time signal, that is input signal as analog signal or continuous signal, then the system given to system, so that system we can call continuous time system, and output it will produces again analog output. Now if you are giving discrete signal, so continuous signal, it will also provide again continuous output. So this type of system we can call continuous time system. Now coming to discrete time system, so input is discrete in nature as well as the output also discrete in nature. So this type of system is called as discrete time system. So it has input and it has output. In terms of discrete time system, we can write this system has h input as x of n is the input and apply to the system, then y of n is the output. So this output y of n is equal to, it is the system function of x of n. System function of x of n. Now signal processing. So signals may be transmitted in order to, so in terms of amplifying or filtering out embedded information, analyzing, or next one is prepare the signal to survive the transmission channel. Next, prevent the interference, that is filtering applications, modifying, compensate, synthesizing the signal. And also we can take in terms of methods to measure, characterize, model and simulate transmissions, and mathematical tools that split common channel and transformations, and which is manipulated in terms of a building block. So these are the signal processing. So here we have modifying, synthesizing, amplification, and everything is coming together to perform this signal processing application. Filtering, amplification, then analyzing, modifying, signal processing applications. Then we have signal processing, that is in terms of so these are the different types of signal processing. So like first one is humans have exceptional nature, right? So in terms of signal processing capability, suppose one of my friend is calling me from the backside, that a human being are good example for signal processing. Like we can hear, whenever we used to heard voice, then we can able to identify, so that is our known person voice or unknown person voice. Similarly, if you are trying to impose on different of images, then I can identify whether it is a known image of any film actors or any known persons or unknown person. I can identify. That is, our eyes will plays, and our controller, that is brain, will plays a very important role in terms of processing a signal as well as processing a human nature, right? So this is a very good example for the signal processing. In terms of human processing, that is identifying patterns, understanding the speech, and generating the spoken language. So by seeing the language itself, we can identify whether it is a Telugu, Tamil, or it is an English or any other language. Now, many types of signals in various applications we have, that is electrical signals. In terms of electrical signals, we have voltage, current, and electromagnetic fields. In terms of mechanical signals, we have motion, force, torque, and displacement. And acoustic signals related to sound and vibrations. And other examples are like temperature, pressure, environmental factors. Then we have the nature world will have most signals, like which are in mostly in terms of analog signals. So these signals change smoothly over time and value. So analog signals, right? Now in terms of sensors and transducers, so these analog signals we will use to convert a physical signal into electrical form, analog signals. So these signals are processed with analog components, say analog components like resistors, capacitors, inductors, and amplifiers. Then analog signals will process. So these are the types of analog signals in the nature world, like a sensors, transducer, that is physical electrical signals. So these signals will be processed through with the analog components, resistors, capacitors, inductors, and amplifiers, and it will process. Those analog signals will be processed, and examples are FM radios and analog methods. Okay, so these are used for FM and AM to process the audio signals. Now we have limitations for analog signal processing. So the name itself, it is a digital signal processing. Why we are going towards the digital signal processing? Because we have some limitations in analog signal processing. So first limitation is accuracy. So accuracy may be affected. Then we have component variations. So as we have discussed, that is, as we have discussed, that is unwanted deviations from linear behaviors like resistors, capacitors, inductors. So because of non-linear behaviors, then it is limited to repeatability due to component variation. Component variation is also one of the limitation in terms of analog signal processing. Next, as temperature increases, those changes, that is environmental changes, will be leads to the change in the temperatures. Now we have temperature and vibrations effects in terms of analog signal processing. And also we have one more limitation is, that is, it is prone to noise interference. So all our interferences, then it is nearby electrical sources. So whatever near electrical sources are there, so that will be affect our components. And it is also restricted in range, that is usable voltages and the currents. Inflexibility, and in some processing tasks it is hard to perform using the analog this signal processing. Next, it is difficult to storing information, so that is very important. Information storage is very important. So like accuracy, component variations in terms of unwanted deviations, repeatability, temperature, vibration, and nearby electrical sources will cause a noise or prone to interferences. Then inflexibility to changes. Then we have difficult to storing applications. So these are the limitations in analog signal processing. So that's why we have moved on to the digital signal processing. Next, this is a digital signal processing. So in the digital signal processing, these are the benefits of digital signal processing, like analog, digital, and digital to analog. So very first block contains analog to digital converter. Then we have applied to the digital signal processing. Then we have again DAC, digital to analog converter. Next, we have benefits of digital signal processing is, which included noise becomes manageable after the signal is digitized. Okay, so after signal digitization, noise is manageable noise, and it is highly linear with limited dynamic range, and a complex algorithm fit into a single chip because of process flexibility is more. Then insensitive to component tolerance, aging, and environmental conditions, like it will not vary with the temperature as well as pressure or volumes. However, it has a drawbacks. So these are the advantages, and for any system we have advantages and disadvantages. But here, in terms of compared to analog signal processing, the digital signal processing having more advantages. Correct. So drawbacks we have is, few drawbacks we have. One is discrete time processing artifacts, that is aliasing effect will occur. So first, this is an analog signal. Analog signal, that is continuous time signal, we can convert it into discrete time signal by multiplying a train of impulses. Right? So this is called it as a sampling theorem. If we am after multiplying train of impulses, so I have, this is a digital signal. 0, then it is 1. Again I have -1. Okay, so as you've seen, it is looking like a sinusoidal signal, but the time is discrete in nature. Time is discrete in nature. So if the amplitude is continuous and time is discrete in nature, so those type of signal we can call it as a discrete time signal. So while converting discrete time signal, the sampling frequency, the effect should be greater than or equals to 2 into FM. If it is less than 2 FM, so it will occur a aliasing effect. Aliasing effect. So care has to be taken while converting from analog signal to digital discrete signal. with the aliasing effect. So that is a one drawback in terms of a digital signal processing. And second drawback is can require significantly more power, that is battery cooling, that is required, more power is required, and digital clock and switching cause interferences, right? So these three are disadvantages for this digital signal processing, but we will mostly prefer with the digital signal processing because of above advantages compared to analog signal processing. Now we have in the next section the real-time applications of the DSP. So the real-time applications are ultrasonic imaging. So we have abundant of applications in terms of medical field, medical fields. Actually, in terms of the communication systems, consumer electronics. So we have all audio, video, DVDs, speech synthesis, speech recognition, then music, synthetic instruments, audio effects, noise reduction. In terms of communication system like modulation and demodulation, channel quantization and echo cancellation. So as if we are considering medical fields, so medical fields we have ECG, EEG. So ECG means electrocardiogram, EEG means electroencephalogram. So to study the heart monitoring, heart beat rate. So ECG will help. EEG will study about the brain structure and brain monitoring system. Then we have suppose MRI scans, X-rays, X-rays. So without these system, we cannot identify what is a tumor or what is the defect in the human body. So in terms of X-rays also, X-rays will be sent over the body, and we can identify, that is doctor can identify where is a fracture, that is bone fracture. Now in terms of gallbladders, baby fetal status, what is the growth of the fetal, so those also with the ultra scans, right? So with each and everything we have this digital signal process. In terms of medical ultrasonic imaging, that also required for the one of the applications of the DSP. So without these, we cannot identify the internal organs of the human body. So these are the very important applications of the DSP in terms of the medical field. So we have communications fields, electronics, audio, video, DVDs, speech synthesis, music synthesis, right? So in all applications, we are using this digital signal process. Now we have one more in terms of not only those fields, we have geographic fields, seismology, oil exploitation from the seas. Then we have astronomy, stars movements, so how stars are moving from one place to another place, aviation radar, then radar, navigation, security, digital water making, surveillance, intelligence, signals in terms of signals, electronic warfare, also one of the applications of the DSP in terms of control systems and pattern recognitions. So these are the real-time features of these um, applications of this DSP. Now we have analog signal processing. So analog signal processing is, that is analog circuits using resistors, capacitors and amplifiers. So this is in terms of electrical signal involving voltage, current and fields, electromagnetic fields. Then other signals we have as, that is signal including pressure and temperatures. Acoustics. So these are the different fields of the signals, like in terms of analog signals. Acoustic signals, mechanical signals we have, like that is mechanical in terms of force, torque, displacement, velocity and all. And acoustic signal like a signals involving sound and vibrations, right? So analog signals we have electrical signals in terms of voltage and currents, and other signals like a pressure and temperatures, and acoustic signals all are in terms of analogous in nature. And this I'm going to explain about the unit 1 is about the signals and systems. After that we will discuss about the discrete time Fourier transform. There we will discuss about the discrete Fourier transform. Then we have in the second unit, that is in terms of fast Fourier transform. So we have so and so some disadvantage in DFT, so that's why we need very fast processors which process our signals. So that's why fast Fourier transform will be used um, to get our solutions very easily. Then we have digital filters. In the digital filter, two classifications, IR filters and FR filters. In unit 3 about regarding the IR filter designing, unit 4 is regarding the digital filter designing. Here I will use the MATLAB simulation to generate the filters as well as to generate the signals and all. And unit 5 is depending upon the multi-rate signal processing, decimation and interpolation, as well as how the realizations of the filters like FIR filters and IR filters realization techniques. Now we have objectives here is first we will go with the at the end of the course you should be able to learn about the how to represent the signal mathematically, mathematical representations of the signal like unit step signal, ramp signal, parabolic signal, then exponential signal, right? So all we have considered here is in terms of discrete time signal. Then we will apply the some basic properties for that is discrete time system, that is classification you will learn after that. Then you will understand how to convert the analog signal into discrete signal by avoiding the aliasing effect. Then we will learn about the convolution process, then explain that is conversion of one time domain into frequency domain representation, and how to convert one domain into another domain. Later on, you will learn about the DFT, how to compute the discrete Fourier transform, and you will also learn about the FFT algorithm, radix to FFT algorithm. So FFT again classified as a two types. One is DIT FFT algorithm and DIF FFT algorithm. Next, designing of different types of digital filters in various domains. Then you will learn about the implement and apply and evaluate the sample DSP applications in MATLAB. So these are the objectives of this course. Then these are the textbook and learning sources, that is reference books we have. Proakis, that is a standard textbook we have for the digital signal processing. Now why to learn this DSP means, so DSP will have so many, so we have, if you are gaining a knowledge in terms of a DSP, so you may have a chance of working with like a Qualcomm's companies. Then we have different companies which are offering and which are actively working on this digital signal process. So these are the applications that is we can use in terms of voice assistants, we can use in terms of car like drones and smartwatches also we will use. In all applications we are using this digital signal processes, and you will learn this DSP. So you may have a knowledge. If you are having a knowledge, then you may have a get a good companies. You can work with a good companies like Apple Siri, Google Assistants, then video. So in terms of drones, surveillance, AR, VR, autonomous cars will use. In terms of wireless, medicals and IoT, smart homes, smart cities. So this DSP is a core engine that cleans, compresses, interprets, and transforms the raw data into usable and intelligent insights. So that's why. So you have to learn the real-time applications of the DSP. That is in terms of you can get a jobs in the companies, various companies like. So this is a job opportunity if you learn in terms of a DSP, that is DSP engineers, signal processing architecture. So this is a signal and systems is a basic subject. After that DSP you have to learn to get a working on Qualcomm. Then we have analog devices, so Apple consumer electronics. Then we have Tesla. So all these are working on digital signal process. So after learning this course, you may have a knowledge that will be helpful for your to work as a DSP engineer, signal processing architect, and machine learning engineer, as in terms of a research scientist also. This is a digital signal processing. This is a digital signal processing definition and all. So in next class we will discuss about these topics. Thank you so much.